Am I audible, sir? And is my screen visible clearly? The screen which I said, engineering mechanics assignment 2, assignment 3, sorry. Am I audible?
Yes, sir.
Okay. So today is the third week we are meeting for the live problem solving class. So actually today I'll not be able to write, so that's why I'll just share the discuss the problems and also share the solution of the same over the screen itself, and I will try to explain. Okay, if you have any doubts over here and all these things, you can ask me. So in the problem 1, so it's regarding the bending moment and the shear stress diagram, and also it's again the problem of statics, okay, where you have no motion, you have to only analyze the uh, the free body diagram of the system given, and then from there you have to calculate the reaction force or the reaction moment, all this simple thing. So let me first go through the first problem. So this is your assignment 3 problem, I guess. Okay, so the first problem says that, so everyone can read the question and the diagram, right? Are you able to see the screen, where I set the problem 1?
Diagram is clear, but question is not clear, sir. And to me, it's not visible.
Diagram is clear, but the question is not visible. Okay. Okay, let me share it once. Is it visible now? The question and the diagram. Not clearly.
Not clear, sir.
And the diagram is visible clearly, right?
Yes, sir.
Okay. So let me go through the diagrams only. I'll try to explain through the diagram. So what it says is that so it says that there is a cantilever beam, if you can see this, and a is the point where you have the support. Okay, I mean the support is in the built-in end of the beam. Okay, so here it is built in the A, and it's a cantilever beam of length 8 meter, and from the end of the beam up to 4 meter there is a uniformly distributed load, okay, which is of 600 Newton per meter. Okay, and what you need to calculate is that what is the reaction force and the reaction moment at the built-in edge. Okay, so you have a cantilever beam, you applied a load of 600 Newton per meter over the length of 4 meter, and you are asked that what will be the reaction force and the reaction moment at the built-in end of the cantilever beam. Okay, so let me share the solution and then I'll discuss it. So now are you able to see the screen clearly, like the writing diagram and the writing? Hmm? Are you able to see the screen? Anyone? Okay. Hello. Am I audible?
Yes, sir.
Oh, so are you able to see the screen now? Like the diagram and the writing, everything, are you able to see?
Yes, sir.
Okay, okay, great. So, as I said, the problem is like this. Okay, so this is your problem where you have a cantilever beam of length 8 meter. Okay, and in from the end of that cantilever beam over a length of 4 meter, you have a uniformly distributed load of 600 Newton per meter, and this is your built-in edge, I mean the built-in end, and you are asked to calculate what will be the reaction force and the reaction moment at this built-in edge. So first you need to draw the free body diagram of the entire system. Okay, free body diagram of the beam in that sense. So for a built-in edge, so in the last class I told that if it's a pin joint, then there will be two like the reaction force will be in two directions, like okay, horizontal and the vertical. Okay, if it's a roller support, okay, then the reaction force will be only in the vertical direction, there will be no horizontal like reaction due to the roller support. But here it's a built-in edge, I mean the built-in end. So one end is completely reinforced with the other structure. So in that case, like when we will draw the free body diagram of that beam, which is of length 8 meter, at for that built-in, I mean at the due to that built-in portion of the beam, you will have a reaction force both along the vertical and the horizontal direction, and you will have a reaction moment. Okay, so I will say that these reaction force are RAX and the reaction force along the x axis. So if I attach a axis like this here, like with origin at the built-in end, and this is my x direction and this is my y direction, so this is the free body diagram of that cantilever beam. Okay, this one is the free body diagram of that cantilever beam, where you can see that it is of length 4 meter, over which the uniformly distributed load of 600 Newton per meter is acting, and the total length is 8 meter, and due to that built-in end you have the reaction force both in the horizontal and the vertical direction, and a reaction moment, okay, which I will consider as a some clockwise reaction moment. Okay, so again for the sake of as like assumption, like I will assume that this clockwise moment is negative and the anti-clockwise moment is positive. Okay, that's what I will assume. So now you tell me that from this free body diagram itself you can calculate that what is the value of RAX what is the value of RAY and what is the value of MA. Okay, so this is a uniformly distributed load of 600 Newton per meter. So what is the total load? That means 600 Newton load per unit length. And what is the total length? Total length is 4 meter. So the total force is 600 Newton per meter into 4 meter is equals to 2400 Newton. And this uniformly distributed load will act in the centroid of this 400 meter length. So what is the centroid of this 400 meter length? It is the 2 meter from the end of the beam. Am I right? Just from the 2 meter from the end of the beam, that is where the centroid of that portion over which the uniformly distributed load is acting. Okay, so the force due to uniformly distributed load will act somewhere here, which is 2 meter from the end of the beam. And if it is 2 meter from the end of the beam, then from the built-in end it will be 6 meter, right? So here you get the final free body diagram. So you have the reaction force RAX, and RAY. Also you have the bending moment, okay, and then you have a resultant of the uniformly distributed load, which is 2400 Newton, which is acting at a distance 6 meter from the built-in end. So now again you have to write the force balance and the momentum balance, like you have to write the force balance thing, and also you have to balance the momentum. Okay, so from here you can easily see that if I do that summation Fx equals to 0, that means all the forces acting in the x direction is 0. So what is the force which is acting in the x direction? Can someone tell me from the diagram itself? Like from this free body diagram you can easily see, right, that what is the force acting in the x direction?
0, sir.
Yeah, so that is 0 because RAX summation Fx equals to 0, that means RAX plus 0 is equals to 0, that means RAX equals to 0. Now similarly, if you do the force balance in the y direction, so in the y direction I have RAY, which is acting to the positive, like y direction. If my coordinate system is like this sorry, if my coordinate system is like this is the positive x and this is the positive y, then RAY is acting in the positive y direction, and the external load, which is 2400 Newton, is acting in the negative y direction. That means RAY, which is positive, plus minus of 2400 Newton is equals to 0. That means RAY is equals to 2400 Newton. So the reaction force at the point A or at the built-in end of the cantilever beam is 0 along the x-axis and 2400 Newton along the y-axis or along the vertical direction. Now in the similar way you can calculate that what is the reaction moment at the end. Okay, so what will be the reaction moment at the end? If you take the moment about point A, so both the force AX and AY are passing through the point A. So about the point A, the moment due to RAX and RAY will be 0 if I take moment about the point A. So then the moment balance, or if I do that the net moment acting on the beam is 0 about the point A, and as I show in this sign that clockwise is positive. Okay, so I am taking the clockwise moment as the positive moment. That's what the assumption I made here. So I told it wrong just few minutes back. So So clockwise is the positive bending moment. If I write in that sense, then at point A, what is the moment? MA, okay, which I need to calculate. And what is the moment of this force? 2400 Newton about the point A. So it will be the 2400 into the distance from the point A, which is 6 meter, and the force is acting vertically downward, so the moment is also clockwise. Am I right? The moment which it will give is also the clockwise moment. Okay, so that means MA plus 2400 into 6 equals to 0. That means MA is equals to minus 14.4 kilonewton meter. So this is in Newton meter. 2400 into 6 is in Newton meter. You do it as kilonewton meter, it will come as this. Okay, so for calculating MA, so MA I saw that the positive direction, that's why, but I got a negative moment. Okay, and in the original assumption I saw that anti-clockwise moment is always positive and the clockwise moment is always negative. Okay, so what is the net force? So these two forces are acting perpendicular to each other, RAX and RAY. So it's the simple RAX equals to 0. So the net force is 2400 Newton, which is 2.4 kilonewton, and the moment at point A is equals to 14.4 kilonewton meter, which is in counterclockwise direction, CCW. Sorry, yeah, CCW. CW is the clockwise direction and the CCW is the counterclockwise direction. So now I will go to the question. Let's see what were the options. Can you see the options? So it will be option number A, I guess. Yeah. So RA is equals to 2.4 kilonewton and MA is equals to 14.4 kilonewton meter in the counterclockwise direction. Okay, so it's a very simple problem. You have to just do the force balance. Summation Fx equals to 0, summation Fy is equals to 0, and the summation M is equals to 0 about any point. That's the three equations you need to satisfy after drawing the free body diagram. Okay, after getting all the forces and moment at the, like, getting different reaction forces and moment, you draw the free body diagram and then apply these three equations. Summation Fx equals to 0, summation Fy is equals to 0, and the net moment is also equals to 0. If you apply these three equations, you will get all the unknown. Okay, and this is a statically determinate problem, because from the three so why I am saying it's a statically determinate problem, let me go to here once again. So how many unknown you have in these equations? Like from this free body diagram, can you tell me how many unknowns are there anyway? From this free body diagram, what and what you need to calculate? RAX, RAY and the MA, and I got that RAX equals to 0, RAY is equals to 2400 Newton, and MA is equals to 14.4 kilonewton meter. So can someone tell me that, so total three unknowns I calculate, RAX, RAY and MA, and how many equations I applied in this case? Summation Fx equals to 0, summation Fy is equals to 0, and MA is equals to 0. That means three equations and three unknown. Okay, so if this is the case, that means by doing applying the simple, like, equilibrium, like the conditions of equilibrium, the forces are in equilibrium. For that, summation Fx equals to 0, summation Fy is equals to 0, and summation, and there is no net moment. If you apply these three conditions, you are able to get the three unknowns. Okay, so that's why it is called a statically determinate problem. So these kind of things are also valid for the problem in the Strasses, okay, which I solved last week. This kind of problems. So as far as the first problem is concerned, you can ask me anything if you have any doubt. So you are like able to understand like the method which like the way in which I am solving, that is important, because the numbers and all these things like that anyway you will be able to calculate, but you just apply the force balance equation and the momentum balance equation, I mean the moment balance equation, you will be able to do the problem. Okay, will be you can easily solve the problem, there is nothing to worry. So is this problem clear to everyone? If you have any doubt, you can tell me. So the things which you need to remember is that for a pin support, okay, you have two kind of reaction force. So the pin support have no reaction to moment, that you need to remember, okay. The pin support will have no reaction to moment, okay. Spin support can only, I mean the spin support, if you have some pin support at any point, about that pin support, that member can rotate. So as the member can rotate, that means there will have no moment, okay. It will not provide any reaction moment, okay. But in case of built-in case, like in this case of a cantilever beam where the one end is fixed, for a fixed support, if you can say in that way, there will be both the reaction force and the reaction moment, okay. And the reaction force and reaction moment, the reaction force will act in the both direction, in the horizontal and the vertical direction, and there will be net reaction force, and there will be net reaction moment. In case of roller support, you will have only the reaction force in the vertical direction or perpendicular to the support, that's all. So if you have any doubt so far, can you you can ask anything. So this is your first problem in the assignment 3. By the way, all of you submitted assignment 3, or you are about to submit assignment 3?
Submitted, sir.
Okay, you have submitted assignment 3. Great.
Sir, but the answers in the solution and we got correct evaluated answer are mismatching, sir.
Okay, so what is the answer in the solution? Solution in answer in the solutions is 14.4 kilonewton meter.
Sir, not this one, sir. In the assignment section, all the correct answers are marked as option A, sir.
All the correct answer?
I mean, here in the solution for second answer is something option B or C, I think, sir, in the solution. But we got correct in the assignment section. It says A is the correct answer, and we got wrong for that.
A is the correct answer as far as the assignment is concerned. I think this is the
not
correct.
First one, sir.
Question number
first
2.
Question, second that yes, sir. 2 and like that coming these questions also, sir.
Question number 2, you are saying that there is something wrong in that as the options.
Sir, no, sir. No, sir. Here in the assignment, I mean the solution is correct, sir. But in the assignment section, it says A is the correct.
Okay, I see. So in the original thing, you are saying that this is the correct answer. they did, is it?
Yes, sir. I marked is option C, but I got wrong, sir.
Mm, okay, but I can't see that thing. Am I able to see that? Oh.
Many of them also posted in the discussion forum also.
Yeah, so but like okay, let me go through the solution for problem 2, then I'll see that like what is the correct answer. So it's saying that a beam is subjected to the variable loading as shown in figure 2, the support reactions at A and B. So it's a very simple problem, if you can see. So like all of you able to see the figure? All of you are able to see the figure, right?
Sir.
Yeah. So what it says is that you have a distribution of load in this fashion, okay, where W is equals to W naught minus K excess cube, where W naught and K both are unknown, and what is given that at point A it has a pin support and point B it has a roller support. So at pin support you will have the reaction force both in the x direction and the y direction, and in the roller support you will have the reaction force only in the vertical direction, okay. And this W, which is in Newton per meter, it is given at point A and also in point B. So that means like what you can do is that you can easily calculate what is W naught and K. That you can easily calculate, right? Like how will you calculate W naught and A? You just put that x equals to 0, at x equals to 0, W is equals to 2400, okay. So that means the W naught is equals to 2400, and also at x equals to 6, this W is equals to 1200, okay. So 1200 is equals to W naught minus K into 6 cube, and W naught I already calculated as 2400. So from there you can easily calculate the W naught and K. Let me go through the. So as you can see here, that first we need to find the values of constant W naught and K, okay. For that we will use the values of load at the given boundaries. So at one boundary where there is point A as the pin joint, you can say that 2400 is equals to W naught minus K x cube at x equals to 0. From there I am getting that W naught is equals to 2400, and at x equals to 6 you can get that K is equals to 50 by 9. So what is the W expression now? 2400 minus 50 by 9 x cube. That's the expression for W. So what will be the total force? If you have W in this fashion, and the W is the force per unit length, so you integrate this W over the length from 0 to 6, you will get the total load, which is 12.6 kilonewton. Okay, is everyone agree with this? Like how the integration will give the total force? Everyone is fine with this, right? So W naught and K you can easily calculate from the given boundary conditions, that at the point A and point B you have already given the load in terms of Newton per meter. You have already given. So from that you can calculate that what is the W. W is varying in this fashion, that 2400 minus 50 by 9 x cube. This is how W looks like. Now the total load is equals to integration 0 to L W into dx. So W is in Newton per meter square. So you take a small width of length dx. So the load which is acting in that small elemental area will be W into dx, and you integrate this quantity over the entire length, you will get the net length, okay. So this net length is 12.6 kilonewton. Okay, that's the total length. And the load will act through the centroid of this distribution, which is at a distance x bar from A. Now I need to calculate x bar. If you read this line, okay, this load, if you read this portion, so this, I know that net load, so the net load is 12.6 kilonewton, okay, but at what point this load will act? This load will act at the centroid of that distribution, okay. And how will you calculate the centroid of this distribution? The centroid of this distribution will be, you have to calculate the total load, you have to calculate the, so W dx is the load at some location x. Now you take the moment of that x W dx from like about some point, so it's basically the area like using the like the centroid of area. It's in the same way you can integrate this quantity x W dx divided by r, that r is the total load, okay. So you are integrating this over the, like you are weighted the every W dx over the entire x, and then you divided by the r, which is the total load. If you do that, you are getting that, like we will get that 2.47 meter is the distance. Now this distance is from point A, that means from this pin joint you will have a load of 12.6 kilonewton at a distance of 2.47 meter. So this is finally the free body diagram of that beam. You will have 12.6 kilonewton at a distance of 2.74 meter. Total distance is 6 meter. For the roller support, you will have the reaction force which is acting vertically upward, which is RBY, and here there are two components of the reaction force, RAY and RAX. Now you apply the simple force balance equation. The summation Fx equals to 0, summation Fy is equals to 0, and summation and Ma is equals to 0. If you do that, you can easily calculate what is the value of RAX, RAY, RBY. All these three unknowns you can easily calculate. Let's see how it's calculated. So summation Fx equals to 0, that means RAX equals to 0. There is no doubt. And RBY plus RAY is equals to 12.6. Okay, so that's in Newton, so that's why 12,600, and Ma is equals to 0 means about this point. So RBY into 6 will be the anti-clockwise, and the clockwise moment is 12.6 into 2.74. If you do that, I will get RBY is equals to 5.74, and if I put that RBY in like here, you can easily get what is RAY. So RAY is equals to 6.84 kilonewton, RBY is equals to 5.775 kilonewton. So the net force is root of RAX square plus RAY square at the point A. Okay, at point A, this will be the vector sum of the two force. Okay, the resultant of the two vector which is acting perpendicular to each other, RAX and RAY, which is coming as 6.84 kilonewton, and RBY is equals to 5.75 kilonewton. So RA is equals to this and RB is equals to this. So the correct option is C. Now someone, let me see what is the correct option here. Yeah, so the correct option is C. Someone was Aditya.
Sir, but in the assignment section it shows A is the correct answer.
And you got 0 in that question, is it?
Yes, sir.
So
Can I share the screen also.
Huh.
Can I share the screen and show
Yeah.
it?
Sure. Sure, you can share the screen and show me. Sure, I have no problem in that. So 1 minute, I'll just stop sharing. Now you share the screen.
So now is it visible, sir?
Yeah. So you put it the option number, this thing, but
See, sir.
okay.
The
1 minute.
accepted answer is A.
I see. So that means definitely something is wrong. So give me a second.
So not only this question, sir. The many three more questions. I mean, many questions are also. It shows A is the correct answer for all the questions, sir. First question is the correct answer in the solution also, sir. But the second one and here the third one also, sir.
Okay, 1 minute. So you told this to NPTEL team? You have send a mail
Yes,
for
sir.
this? Okay, what
So
they
in
are
the
saying?
discussion platform, many of them posted, sir.
Yeah. So that means there is something wrong in that. So it's their fault. I don't know what they did. Anyway. So that means definitely there is something is wrong. Yeah. So your answer is correct. Like whatever you did is exactly right. But there in the system it's showing option A.
For all the questions, sir.
For all the
It's a
questions.
default.
Okay, so
For
what
all
is the next
the
question where you
A
have the
is the
problem?
correct answer.
Okay, so except question number 1, in all the questions this is the case.
No, sir. It shows A is the correct answer for all the questions. But in some question, A is the correct answer in solution also, sir.
Okay.
It shows the default option A for all the questions.
Okay. Understood. So there is something is wrong. They did. I have to let them I have to told them to change it. So when they put the question in that portal, they probably selected A as the default correct answer, like correct option. That is how they did it. Anyway, so like you don't need to worry. Okay, I will tell them and you will get the correct, like you will get the right marks for the right question. Okay, there is nothing to worry.
Okay.
I'll tell
Okay.
you.
Thank you, sir.
So yeah, I'll just go through one or two more problems and then I'll stop. So is everyone else is able to understand, right? If you are not, please let me know. At least the procedure which I am applying to solve the reaction forces and the reaction moment, as far as only the free body diagram is concerned. Great. So everyone is able to understand. And also these type of questions will be there in your NSEM. Okay. Particularly the statically indeterminate problem, statically determinate problem. So you have to make, like, I can remember that at least there are 4 or 5 questions like there in the NSEM. So you have to follow it carefully. Okay, so I'll think I'll solve the question number 3. That will also an interesting problem. So let me go through question number 3 and 4. Yeah, and then the bending moment and shear force diagram is also there. A lot of problems. Okay, so let me go to the solution of this. So it says, let me share the screen. Are you able to see the screen? Fine, right? That is the diagram you can see, I guess. Okay. So it says that
Yes.
the reaction at A due to the uniform loading and the applied couple at as shown in figure 3, which is this figure. Okay. Then again the CW stand for clockwise and CCW stands for counterclockwise is. So you need to calculate that what is the reaction force and the reaction moment at the point A. So it's the exact same thing. What you need to do, like without going to the detailed solution, you can do it. How? So it's 2 kilonewton per meter. Okay. So what is the net force which is acting due to this distributed load is 2 into 3, because it's distributed over a length of 3 meter. So that means 2 into 3 is 6 kilonewton is the total force which will act at the centroid of this portion over this 3 kilonewton portion. It will act. So that is in 1 point. 1 minute. 1 minute. Just give me a minute. I'll just. বল, আমি প্রাইজ পেয়েছি নাকি? আমি তো ইয়েতে চলে এসেছি, আমি তো তোর এখানে চলে এসেছি, আমি তো এনপিটিএল ক্লাস আছে আমার। তা তুই 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 কালেক্ট করে নে, আমি করে নিয়ে নেবো আমার। তাহলে কি আমি তাহলে কি আমি এখন আচ্ছা আচ্ছা জিজ্ঞেস করো। Hello, am I audible? Okay, just give me. হ্যাঁ, হ্যালো হ্যালো হ্যালো। আরে আমি তো রুমে চলে এসেছি, আমার ওই এনপিটিএল এর ক্লাস চলছে। তাই নাকি? আচ্ছা 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 আচ্ছা। তো ওটা মানে অন্য তোমাকেও কালেক্ট করে নিতে পারবে না, আমি পরে নিয়ে নেবো। আচ্ছা ঠিক আছে ঠিক আছে। So yeah, so if you can see that, so without going to the details of the problem, let us solve it. Like I will not go into the details of the solution, but I will tell you that how to solve it. Okay. So as I said that you have a uniformly distributed load of 2 kilonewton per meter. So what is the total force? It is the 6 kilonewton, right? So the 6 kilonewton is acting over a length of 1.5 meter. Okay, am I right? Can everyone see this? Hello?
sir.
Yeah. So in the free body diagram, what will you have is that at point A you will have a horizontal reaction force, you will have a vertical reaction force. Okay, at point A, here you will have a horizontal reaction force, you will have a vertical reaction force, and you will have a vertical external load which is of 6 kilonewton at a point 1.5 meter, and then you have the moment which is 12 kilonewton per meter. Okay, fine. Now let us then, after drawing this free body diagram, you just apply three equations. So what is the three unknowns from here? Can anyone tell? This type of question they will definitely ask. So in the end sem you will get a question like, they will just give a diagram like this, okay, and there will be some let's say a pin support here, okay, and they will ask that is it a statically determinate problem or a statically indeterminate problem, or there might be asked that what is the net reaction moment at the pin support. Okay, so the net reaction moment at the pin support is 0. You can easily say that. That's right, because about the pin support it can rotate. Okay, so you have three unknowns, two reaction force RAX and RAY, and one moment reaction which is MA. Fine. Am I right? Now let me go to the final solution. So in all these classes only these 3 or 4 students are joining, right? Fine. So just you apply the same rules here also as I told, but here in the moment balance equation there will be some extra moment which is external moment 12 kilonewton per meter. If you do this, the moment will come as 3 kilonewton meter, and yeah, it will be 3 kilonewton meter, and the net force is 6 kilonewton, because RAX equals to 0 and RAY is equals to 6, so the net is 6 kilonewton meter. Is that fine to everyone? So here also again Athia, so like for this question also you got 0 marks, but you did it correct, is it?
Yes, sir.
Okay, so I'll send a mail to NPTEL team, like those who have already, I think everyone submitted the quiz, like assignment 3 things, right? Because the last date is over. So
That is over, sir.
yeah, I'll check it manually, and I'll like give you the marks for the right answer. There is nothing to worry.
Okay.
Okay, so the last question, only this question I will solve, and then I will stop it here because I have some other works today. So any will you be able to join in some other time today, like in the night time? Everyone is free? Then I can go through all of the problem, and I will stop it now. Is that fine for everyone? Let's say around 8 o'clock in the night, or let's say tomorrow around 3 o'clock tomorrow. Or tomorrow in the evening.
Today night 8 o'clock, sir.
Today night 8 o'clock will be fine for everyone, those who are like joined already now.
Yes, sir.
Okay, so Athia, are you free for that time?
Yes, sir. Yes, sir. No problem, sir.
Okay, so I'll stop it here because I have some urgent call I got. So I'll stop it here and I'll just go through because these bending moments, air force diagram and all these things, it will be not like, it's better if I don't do this to this way, and I'll solve it either in pen and paper, or like at least I should explain it little rigorously, because this is an important
Sure.
concept.
Where can we get this explained solution, sir?
Yeah. Explain solution. They are not sharing with you by any way, NPTEL team,
Oh,
in that portal.
okay, sir. Okay. Okay, sir.
No. Like, you check and tell if they have already shared it, then, because we have already shared with them. I mean,
Sir, actually, those are not shared with us. And sir, I was also having one doubt. I have missed my earlier session, so if I have some doubts regarding assignment 1 and 2, can I ask you?
Yeah. Sure. If you have any other doubt,
Okay.
you can ask. So you join in the 8 in the night. I'll definitely answer all those questions. Okay.
Okay, sir. Thank you so much.
Okay. So it will be the same link. You join in the 8 in the night. I'll definitely go through all the doubts. Okay. Okay. So I'll stop it here.